All right, so lesson 6.7 is talking about applied problems. So they're now giving you some more in-depth things that you need to solve, not necessarily saying we're going to have you do this one thing over and over again. So the first example is asking us just to solve this triangle, and that's what a lot of your homework is. When they say solve this triangle, they just mean you need to find everything that's missing, okay? So they're telling me that this little symbol right here is gamma. Angle gamma is 90 degrees. That's this one right here. And then alpha is 34 degrees, so I went ahead and marked that right there. And then side B, which is a lowercase b, is 10.5. So that's the side that is opposite angle B. So I always draw this same triangle, this same right triangle, and I always label it A and then B up here and then C. So then this side over here is always B. So what's missing? What's missing is this side A and side C, those two sides, and then one of the angles. Angle, I'm going to call that beta. That's missing. So the good thing is I'm going to go ahead and find that angle because that's the easiest thing to find. So if you have two of the three angles, you know that the angles in a triangle add up to 180. Or you could say these two add up to 90, right? With this one being the other 90. If you have two of the three sides, you could use Pythagorean theorem to find the missing side. So I would always do that one first. So let's say I take the long way and say I'm going to add up my 90 and my 34. And I'm saying this is the long way because what I could have done is just said 90 is what's left over. So 90 minus 34 would be my answer. Or I could go the long way and say, well, 180 is my total, and I'm going to minus away those two together. And that's going to give me 56 in this case. So that is beta for me. So there's one piece. I need three answers because I'm missing three pieces of information. So my other two, I'm going to have to think about my trig functions. So I'm going to go off of this angle right here because what if I messed something up and got this wrong, right? So let's use what we already know, what we were already given. So I was given this angle of 34. If I'm going to find side A, that means I have the opposite side is what I'm looking for. And I have this side right here, which is my adjacent side. It's adjacent to this angle right here. I don't have my hypotenuse, so I'm not going to worry about it right now. I just have opposite and adjacent. Well, opposite and adjacent is tangent. So think about your SOHCAHTOA rules. So if I have opposite and adjacent, tangent is what I should be using. All right, so the tangent of angle 34, the angle 34 degrees, equals my opposite over my adjacent. So that means if I multiply both sides by 10.5, that means 10.5 times the tangent of 34 will give me A. So I just used a calculator, and on mine I got about that. Now in your book, they actually rounded that to 7.1. So it doesn't specify, it just gives an approximate answer. So actually I think it says give the exact answer, but I'm not going to be too mean about that because that means I would have had to take this and make it a fraction, or if I'm talking about angles, if they don't come out perfect, I got to have my degrees and my minutes. So instead I'm just going to say, you know what, decimals are okay with me. I prefer 2 digits after the decimals, so not the tenths, but the hundredths place. But it looks to me like in your book, they're doing a lot of tenths places. So if you made this 7.1, I'm okay with that. Okay, the other side, the third side, I have two options here. I could use trig functions like I did on this one, or I could use Pythagorean theorem. I am not choosing to use Pythagorean theorem because I don't want to have to deal with something that I have rounded. If I round something and then use it to find something else, that answer that I just found is less accurate. Okay, so I'm going to go ahead and use my trig functions again. So this time, I'm no longer talking about my opposite and my adjacent. Now I'm talking about my hypotenuse and my adjacent. So, and again, it kind of depends on which one you want to use. So let's say I want to use my my adjacent, which is 10.5, and my hypotenuse of C. That would be adjacent over hypotenuse, which would be cosine. of 34 equals my 10.5 over C. Okay, so that would be C cosine of 34 equals 10.5. So then I'm going to get, if I find my C, that means I'm doing 10.5 divided by my cosine of 34. So I'm going to use a calculator to show you how I'm doing this. All right, so I've got 10.5 divided by the cosine of 34. So I'm going to do, first of all, let me go back and make sure that I'm in degrees, which I am. So then get out of that. So then I'm going to do my cosine of 34, and then I'm going to take 10.5 divided by that answer. So I'm getting C is about 12.67, about 12.67. Again, in your book, they probably would have just said 12.7. Another thing that you could do here is you could check these answers. You could say 7.08 squared plus 10.5 squared equals 12.67 squared and see if that actually works. But there's my 3 answers. All right, now the second one, same thing. They want me to solve. Now, I didn't put anything in because I wanted to show you. I wanted to remind you how I put everything in. So my gamma is my 90-degree angle. That's this one. I've already got it. Then they said side A is 12.3. So the side opposite, angle A, is 12.3. And then the side opposite, angle B, is 31.6. So that means I'm looking for side C, this right here. I'm also going to be looking for this angle right here, and I'm going to be looking for this angle right here. So I'd call those alpha and beta, depends on how you want to write it. You could literally call them just capital A and capital B. That's fine. Okay, so I'm going to use Pythagorean theorem for my first one then. Because I have 2 of my sides, I can find my third one pretty easily. So A squared plus B squared equals my C squared. So 12.3 squared is 151.29. 31.6 squared is 998.56. So if I add those together and square root both sides, that's going to give me C. So that plus, okay, so that gives me about that, not about, exactly that. So then when I square root that answer, I am getting, you can kind of see it right there, I'm getting about 33.91. So I'm going to round it to 33.91. That's about what C is. There's one of my 3 answers. And then again, I'm going to start figuring out my angles. So let's say I start with this one right here. I have the opposite and I have the adjacent angles. So again, I'm going to use tangent because I have opposite and adjacent. So tangent of, I don't know what the angle is, so I'm going to say tangent of my alpha is going to equal my opposite over my adjacent. So the first thing I would do is get this as a decimal, and then to find this, I would do the inverse tangent. So this is going to be the inverse tangent of whatever that 12.3 divided by 31.6 is. And you don't have to write that step, I'm just showing you what I'm doing. So I'm going to take 12.3 and divide it by 31.6, and then I'm going to do the inverse tangent of that answer. So I'm getting that my alpha is about 21 point, I'm going to call that 27. And that's degrees. Again, in your book, they asked for an exact. So if you look at the back of the book, they would have written this as 21 degrees and so many minutes, right? So if you want to convert that, that's that, how many out of 60 is that? You can do that conversion if you want, or I am perfectly fine with you just leaving it as a decimal, okay? All right, my other 1, so I got to find this angle right here. At that point, I would just use, they add up to 180, right? So 180, I'm just going to use 90 instead. So I already know this 90. So that means these two added together have to be 90. So 90 minus my 21.27 is about 68.73. That would be about my beta angle. Again, that's approximate because we rounded that last one, but that's fairly close there. Okay, the last example that I want to talk about is more of an actually applied problem, which is what this lesson is supposed to be about. So this one says, from a point on level ground, 135 feet from the base of a tower, the angle of elevation of the top of the tower is 57 degrees, 20 minutes. Approximate the height of the tower. Okay, so I'm going to draw myself a picture. Basically, here's what happens. Here's my starting point, and 135 feet away, I've got this tower towering up in the air, right? And what they're telling me is the angle of elevation, which is this angle right here, like how far up is that angle to the top of the tower? So the angle of elevation of the top of the tower is 57 degrees, 20 minutes. So that's that angle right there. I know that this one right here is a 90-degree angle. They want me to approximate the height of the tower. So that's that height right there. Okay, so if I'm looking at this angle right here, I'm just going to first get my bearings straight. I have my opposite and I have my adjacent, which again is tangent. Now, not all of these are going to use tangent. It just happened that all three of them did this time. But the tangent of that 57 degrees, 20 minutes is going to be my opposite over my adjacent, right? So what I'm going to do is multiply by 135. 57 degrees, 20 minutes. And that's going to give me my H, but let's go back for a second. This is in degrees and minutes, which I cannot type into my calculator as is. My calculator is not going to recognize degrees and minutes. So instead I have to convert this to just degrees, maybe as a decimal, right? So 135 times the tangent, I'm going to make this 57, and 20 minutes would be 20 out of 60. Right? Because there's 60 minutes in a degree. So really this is the same thing. Let me just simplify it one more step. 20 over 60 is the same thing as 2 over 6, which is the same thing as 1/3. So I really have 57 1/3 degrees. So I'm going to take my calculator and type that in like a fraction. So I'm going to do the tangent of 57 and 1/3. That's going to give me just that degree, the tangent of the degree, and then I'm going to multiply that by 135 because it was 135 times that tangent. So that gave me 210.55. So let's see. They told me to approximate it, so I'm going to do that here. I'm going to say, you know what, this is really 210.55 is really about 211 feet. And maybe you say that's how high the tower is. It's 211 feet high, or just 211 feet, okay? So there's my approximation, and I'm good to go.